Just don't unsubmit because I can see that, right? This is it. All right. So consider a regular polygon below. So I'm telling you this is a regular polygon, right? First off, label one interior, one exterior, one central. So it's the ice, right? So central should be, right, two corners, consecutive corners connected to the center. That's your central angle. Your interior would be any interior corner of that shape. And the exterior angle is just found by extending one of the sides, right? And then you have your exterior angle there. So that'd be 3 marks, 1 for each. And I did give you some of the formulas up here. Not that it matters, you should have your study sheet or your formula sheet anyways. Calculate the sum of interior angles. You have determined that it's a 9-sided polygon, right? You just count. I actually counted them, right? And you can see the numbering there. So sum is just 9 minus 2. So n minus 2 times 180, which is 1260. So you got the 1 mark there. Calculate the measure of one interior angle, and that's n minus 2 times 180. Okay, I got you, Christine. And it's divided by 9. So it's basically 1260 divided by 9, which is 140 degrees. So each one of these interior angles here is going to measure 140. Calculate the measure of one exterior angle. You either use the formula 360 divided by n, or you go 180 minus the interior angle. Both of them should give you 40, regardless of how you did it. You should be familiar with both methods, because sometimes you'll need one to find the other. Calculate the measure of the central angle. It's 40 degrees as well. It's just 360 divided by n. The number of diagonals. This one is n minus 3, right, which is that 6. So 9 times 6 divided by 2. This should always be a whole number, folks. If you get a decimal, you made a mistake. Okay, it should always be a whole number. What's the sum of all exterior angles? That's just a concept, and it's 360 degrees. It's always, right, the exterior angles always add up to 360. So that would give you a mark out of 9 on this page so far. Backside. If a polygon has a central angle of 20, how many sides does it have? A central angle of 20, right? We didn't do a question like that, but really it's the same as if I had given you the exterior angle, right? Because exterior and central are always the same. So you start with this formula. You know what C is, right? You plug that in, and then it's cross multiply and divide. So it's 360 times 1 divided by 20, so you have 18 sides. Okay, so I give you 1 mark for the work, because if you just come up with 18, I see that quite often, right? Just miraculously come up with 18. I wouldn't give you marks for that because I know you can guess and check, right? Until it works out. So you're supposed to show algebraically, right, your steps, how you got there. Number 3, now we're talking hexagon, n is equal to 6. And so the sum of interior angles is just n minus 2, which is 4 times 180, so that's 720. Central, it's all over again, right? It's the same thing, it's just a different shape. 360 divided by 6, we got 60 for the central angle. Measure of one interior angle is just 720 divided by 6, right? It should be 120. Number of diagonals that can be drawn is n, which is 6, times n minus 3, which is 3, divided by 2. So that's 18 divided by 2, you get 9. Number of one exterior angle is 60. It's just 360 divided by n. And last, consider the following 5-sided polygon. Determine the sum of interior angles. 5-sided, the sum works for any polygon, right? So you go n minus 2 times 180, you get 540 is what all of these are supposed to add up to. And then you go and say, okay, 540 minus the 290-degree angles that are over here, minus the 151 and minus the 149 will give you x, which is that remaining angle. So it should be 60 degrees. All right, so out of 9 as well, so we got 18 total. And now you know how these work. We'll do another AC on Monday, but this one I will mark. Okay, so let's put that away for now. And let's go over to this one. This handout that you should have in your package that you received as you came through here. Just a reminder that as you come through here, there's a lot of handouts for the probability unit, as well as the booklet for the probability unit, and 2 exam booklets that will help you review for the cumulative that's coming up. Okay. Ona, you asked me about vehicle finance on the test. There's one vehicle finance question, and I will say that it is fuel economy related. So if you want to narrow it down, I hope at home you heard me too. It's fuel economy related. Just one question. The rest is all angles and some trig. Right? You got trig shows up. As you can tell, yesterday we did some trig, right? To find the perimeter. So let's fill out. I won't do every single question, right? But I will. I want to go through. I will pick and choose, and then if you want the whole answer key, I might post it later, and then you can check every single one if you'd like. Okay, so Heptagon, you should have that list on page, I believe, 203 has all the names, but we know that if it's a heptagon, n is equal to 7. So sum would be n minus 2. I can't stress enough, it is important to keep the formula in mind. Don't just blindly do this and then later you forget, right? What is it that I have to do here again, right? So 5 times 180 would be 900 degrees. That's the sum of interior angles of a heptagon. Each interior angle they want here, the interior angle is n minus 2 times 180 divided by n. So that would be, here we can do that, right? We can go 5, right, times 180. I'll do that already. Divided by 7. So I is going to be 128.57, and make sure you round to 2 decimals. Not all of them have a decimal for their interior angle, but quite a few do, right? Sum of exterior angles, it's always 360. And you can put down 360 for all of the ones. Doesn't matter how many polygons they would give you, just fill that in, 360. Each exterior angle is 360 degrees divided by n, so it would be 360 divided by 7, or you just go 180 minus this, right, to get that, and that's 51.43 degrees. Number of diagonals, use this formula, n times n minus 3 over 2, and that'll be 7 times 7 minus 3 over 2, which would give you 14 diagonals on that one. Same here, at 20 gone, I'll just go 20 minus 2 times 180. That's 18 times 180. And that's 3240. 3,240 degrees. Don't forget your degrees. Interior angle is going to be 18 times 180 because it's n minus 2 divided by 20. So you notice that it's always 2 less up here compared to down here. and that's 162 degrees. 360, that's done. Let's do some mental math. Exterior, it's 180 minus this, right? So that should be 18 degrees. Or you can go 360 divided by n divided by 7. I should, no, sorry, 20, which is 18 degrees. Regardless of how you do it, you get there. And then for the number of diagonals, watch this. This is a pretty big number. So that would be n times n minus 3 over 2. That's 170. Can you imagine drawing 170 diagonals, right? It'd be pretty crazy. No thanks, right? And so, sorry, I should say n at 20 gone is just n is equal to 20, 41 gone, right? It's 41 sides. I'll give you the numbers here. 360, 8.78, and 779 diagonals on that one. And I'll just make a note down here. This one and this one add up to 180. They're supplementary, okay? So this column, right, like these two should always add up to, it's almost like the interest, right? Or your payment is equal to principal and interest. If you have one, you can find the other. Okay. And then we have some backwards here. This is backwards. Those are important. There won't be a whole ton of them, but one for sure on every test or something like that. The sum of interior angles is 1980. How many sides? How many sides? They want n, right? They're asking for n. Does this polygon have? So it's the sum. I'll highlight that. That is the formula we're going to use. They give us what it is, and they want the number of sides, right? So sum is equal to n minus 2 times 180. Sum is 1980, so make sure you write this down. Okay, if you're not comfortable with this, I will show you how to do this, okay? When you have this, I will use a different color. Don't worry about the n minus 2 just yet. Just know that 180 is multiplying this whole thing. So we're going to get rid of the 180 by doing this. We're going to divide this whole side by 180, and we're going to do the same thing to the other side. That way we can cancel this here. Okay. So you are left with n minus 2 on this side. You can get rid of the brackets because there's no longer the 180 next to it. And here you just type that into your calculator, right? You go 1980 divided by 180. The math always happens on the other side, right? So it's 11. And then at this point, the 2 is subtracting from n. So we're going to go plus 2 here, and we're going to go plus 2 there. And n on this side, right, you're left with n there because minus 2 plus 2 is 0. So 11 plus 2 is 13. 13 sides. Okay. So there you have it. If you distributed the 180 into it, you'll get the same answer, right? If you go 180 times n, 180 minus 2, it's a little different, but it still works. If each of the exterior angles is 15, how many sides does it have? This one you should know how to do, right? We know that the exterior angle is found by using, you have to start with the formula. And then E is given to you. So 15 degrees is equal to 360 over n. You put the 1 here, cross multiply, divide. So it's 360 divided by 15. And that is 24. Then we're supposed to come up with a number of diagonals. I don't know why I give you a heptagon again, but hey, it is what it is. 1, 2, 3, 4, 5, 6, 7. N is equal to 7. Diagonals, right, are found by going n times n minus 3 divided by 2. Sound like a broken record, right? And that is 14. 14 diagonals. I don't know if anybody tried drawing them. I don't know if I should do this, but I'm going to try 1, 2, 3, 4. So I have 4. Different color. 5, 6, 7, 8. So I have 1, 2, 3, 4 again. I'm going to use my pencil. I'm probably going to mess this up, but hey, 1, 2, 3. I'm going to add 3. So 4 and 4 is 8 plus 3 is 11. I need 3 more. I need a different color. I'm going to use this highlighter. I'm going to go from here. From here, this is 1, 2. This is already connected. Can't go there. I can't go there. It's already, so I need to add 2 to this. We're at 13, so we need 1 more according to this, right? And this is I shouldn't have done this because now I'm gonna stress over this. Anybody see it? 4 and 4 is 8 plus 2 is 10 plus 3 is 13. I can guarantee you there are 14. There's one left that I'm not seeing. Oh yeah, here. From here to here, that's the one. Plus another one, so that's 14. 14 diagonals. So you could do it by actually drawing them out, but I would not recommend that because it gets, you miss one, the whole question is wrong. Okay. Backside. That one, I will just give you the answer. That's pretty straightforward. You can tell by the marks. I gave them to you just so you know what that would be worth, right? Assume the following is a parallelogram. This is actually an important one right here. Okay, so if you're falling asleep at home, bottom left to bottom. Okay, thank you, Jello. You were helping me out. Yeah. This is important. The concept that I'm about to talk, students forget that straight lines add up to 180. And I can see why, because you're overthinking it, but it's actually the most helpful property that you can think of. Well, anyways, this is a parallelogram. A specific name is given. What does that mean? This is parallel to that, and this is parallel to that. Right? That you should be really good at, like graph a shape and come up with the properties of it by using markings, right? We know that this angle is going to be the same as that one. So we can go ahead and just write down 73 degrees for x, right? These are the same. And how do I get z? I have nothing across from it. Well, we know that these two add up to 180. I showed you that in your notes on page, I think 190 or something like that, when we talked about all these quadrilaterals. So z, here you have to do a little bit of math. You got to go 180 minus 73. And that is 107 degrees. Okay? So that's how I found this, knowing that these two are 180. Now I know that this angle, so this angle right here, I'm going to use a double arc, is the same as this angle down here. So it's all about knowing your properties. So if this is 107, then this is 107 also. And now you should see that now we're talking about the straight line that is down here. This angle and this angle y add up to 180 as well. So to get y, we're going to go 180 minus 107 as well. Don't you love highlighters? I used to not care about them. Right? This angle there. And you get, yes, you guessed it, you get 73. Sometimes you'll be thrown off by things being the same. That's fine. Okay, don't worry about that. If you know what's what, right, you'll be fine. And if there had been a triangle anywhere, maybe I'll use that. Maybe you should copy this because something like this shows up from time to time. So let's see you have something like this. So it's just one line here. Just make sure you have a triangle. So I have this line here. Go out of that line, extend it, and then make another. Just make sure you have a triangle appearing there with some extensions. So let's say the question says that this is 150 over here on this side, right? This is 150 there. This is, let's say this is 60. And I'm just making this up, so I've got to make sure this works. So hold on one second. This would be, yeah, this is 30 degrees in here. So the one inside the triangle is given. So you have things on the outside of the triangle, and I'm asking you to find x. So let's put x here, that's a degree, and this is y here. So this angle is x, this angle is y. So if I asked you for x and y, right, first of all, x here is along a straight line. So 60 and x add up to 180, right? We know that the 150 and y are also along a straight line here. So you use the supplementary angle, the straight angle properties to come up with that. So x is going to be 180 minus 60, which is 120, right? And y here is going to be 180 minus 150, which is 30. Okay. And technically, I could have left this one blank and called that z. And you could have found that by knowing that the angles in a triangle add up to 180, and then you could have gotten that sliver in there. Okay, so use those properties wisely. They're very helpful. All right, keep going. Given a regular hexagon with center C, determine the measure of the central angle of a hexagon. So I'm going to do that. Central is 360 divided by n, which is 360 divided by hexagon. N is equal to 6, right? So I'm going to plug in 6. So it's 60 degrees for. I will use different shapes. It won't always be hexagons, guys. It won't always be hexagons, pentagons. So make sure that you know that the name goes with a certain number of sides, okay? And then determine the length of side A. So this one we did yesterday. If this is regular, then all the sides on this polygon are the same. Meaning that the legs here will also have to be the same because it's a symmetric shape, right? It takes the same distance going from a center to this corner than it goes from here to there, right? So these are, we got to use our double lines here. because we're not saying that these are the same as the outside sides, right? So this is 16 there. And we just found out that the central angle is 60. Okay, so now we can use trig to find A. A squared is going to be 16 squared plus 16 squared, right? Because it's an SAS. So this squared and this squared minus 2 times the one side, the first side here, times the second side, they happen to be the same, times cosine of that 60. Remember, this angle is across from this side. A is, let's plug that all in, and it actually ends up being a nice round number, which won't always be the case, but it's 256 exactly. And in this case, it ends up being exactly 16 units. And you probably like, why did we do all that work, Mr. Dirksen? Because I don't want you to think that it's always going to be the case. But if you could have already made this conclusion just by looking at this. If this is 60, this is your top angle, and you have two legs that are 16, you know that these two angles will be the same as well. So you could have figured that out, that it has to be 60 all around, and it's an equilateral triangle. So if I asked you what kind of triangle is this, so if we go A, B, can you add that here? So we're going to add C here. What type of triangle is ABC? Or classified triangle ABC? Equilateral. Because we know that this is telling us that not only are these sides 16, but also the bottom A here is also 16, right? We figured that out. So then we can assume that it's an equilateral. What's our time? Ooh, time has flown by. We still have just this little bit here. This is important, okay? I would like you to ace a sketching question, if possible. It's easy to do. It's not that difficult, okay? Sketch a rhombus and label all congruent parts, all. That's what I'm doing here because it's a homework question, right? So we're going to do all congruent parts. It's going to be, maybe I should make it a little bigger so that it's not too crowded. Just make sure it looks like a square, okay? Rhombus has all four sides the same, so don't make it look like a rectangle that's slanted. So boom, 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 right? And then we know that this one is the same as this one. We know that this one is the same as this one. That's it. Like, that's normally as much as I would ask you on a test. Two properties. We know that this is parallel to this one. We know that this one is parallel to this one. We know that the diagonals, maybe I use a different color for it. We know that the diagonal here, there's always a short and a long, right? We know that they're bisected. So we know that this stretch is the same as this stretch. Yep. No, you don't have to. Just draw the line. Yeah. And then this is 1, 2, 3. 1, 2, 3. Don't use 1 again, because then you're saying that these stretches are the same as the outside ones, right? So don't do that. So I wouldn't ask you to do the full deal, but anyways, that's that. And you should know your kites. You should know all those questions there. 9, looking at the chocolate bar from the top, Mr. P states that it looks like a rectangle. Feels like deja vu, right? I've done this before. State 2 properties of his chocolate bar that make it a rectangle. 2 properties. So all 4 corners have a 90-degree angle. That's good. That would be 1. 2 pairs. Oh, never mind. 2 pairs of parallel sides, 2 pairs of congruent sides, yada, yada, yada. I'm going to post this key online because the true and false, I think, would be nice for you to have. So other than that, have a good one, guys. Have a good weekend.